Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, is that a robot scientist? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week I'm focusing on robots in chemistry labs and how they can help scientists to discover new materials. Before we get started, I'd like to invite you to join the Robot Talk community on Patreon, where I'll be sharing behind the scenes updates and you can chat with me and other Robot Talk listeners. You can also sign up to support the podcast for just £5 a month. And if you do, not only will you get a warm, fuzzy feeling for helping me to keep producing and expanding the podcast, but you'll also get access to exclusive bonus episodes and lots of other cool perks. Check out patreon.com/Claire Asher to find out more. The first 20 Patreon supporters get a free sticker, so don't procrastinate, join today. So, with all that said, it's time for me to introduce this week's guest. I recently had a great chat with Gabriella Pizzuto from the University of Liverpool about intelligent robotic manipulators for laboratory automation. This week, I'm chatting to Gabriella Pizzuto, a lecturer in Robotics and Chemistry Automation at the University of Liverpool, working on intelligent robotic manipulation for laboratory environments. Hi Gabriella, great to have you on the podcast.
Hi Claire, thanks for having me. It's really lovely to be here with you.
So you're working on creating the next generation of robotic scientists to accelerate material discovery. So can you explain what that means?
Yeah, so what we're really excited about is developing and deploying robotic systems in chemistry labs. So think about materials, right? Materials surround everything in our lives. We have pharmaceuticals, we have clean energy, batteries. These are very important global challenges. So what we're trying to do is that we deploy these robotic systems to accelerate the process of discovering new materials, creating materials, and analyzing materials. And my specific research area is trying to focus on robotic manipulators. So think about robot arms moving samples around, loading different instruments in labs. And the goal is not, of course, to replace human scientists, but to be able to continue experiments round the clock and also minimize exposure of these chemicals to humans.
Yeah, I think often, people who work outside science, if you say the word material to them, they'll probably think of like fabric and clothes. But obviously, material is a much bigger concept than that. And a lot of new materials for various technologies, as you've kind of just mentioned, are developed in chemistry labs. So this is about automating that process, not something to do with fabric or, clothing manufacture.
Yeah, so I think in labs, it can take in different shapes and forms, and we do early stage material discovery. So we're not even at the stage where we have a full material, like a piece of cloth, or even like polymers, like plastics. So in the labs, even like for discovering new drugs, you would have reactions that create like some powders, and then you could add some solvents, and then it becomes a mixture. To me, it's like making a cake. That's how you do materials discovery. And then you put it in some oven and analyze it. You can look at different patterns of the materials, how molecules interact together. Of course, that's not my field. I work more on the robotics and automation side of it. But that's the whole process that we're trying to automate in a very nutshell, let's say.
So your background, your previous research was on robot learning, and some of your work was in humanoid robots. So what kind of attracted you to move into working with laboratory automation robots?
Yeah, so I've always been fascinated by robotics in general. So since my undergrad, I got hooked on robotics. We had this little mobile robots, which I did for my undergrad. So at that time was more about mobile robots. When I moved to the UK, I was working with manipulators at my master's, and then I did my PhD with the iCup humanoid robot.
Yeah.
And all of it was very much in a robotics center, which is really great for learning and for interacting with robotics researchers. But at the time that I was thinking of, I had moved to Edinburgh to do my postdoc at the time, and I was thinking of continuing working with robotic manipulation. Manipulators, I would describe them humanoids with less degrees of freedom to some extent, so less joints, so
Yeah.
more or less the same thing. But at that time, the COVID pandemic hit, and I was working in simulation, as most labs were doing, and I saw this opportunity in Liverpool, and it was like, oh, they're going back in the labs because physical scientists and chemists were going back to the labs because, of course, they need to carry out their experiments. And I was like, oh, that's how I can get back into a robot lab, you know? So I thought, oh, that's really cool. And lab automation is something that I had no idea what it really was. And there was this exciting European project. And it seemed to me like the excuse to get back into the lab. And then I really enjoyed it because we were deploying robots in a chemistry lab. So it was actually doing something that I was really passionate about because I could see the robot being used by chemists, being used by different scientists. So for me, it was really important to see my work having an application side to it, especially being an academic. I think it's not very often that we have this opportunity unless we collaborate with industry to some extent. So to be able to experience it every day, I think was really, really exciting for me.
Yeah, that makes sense. It's interesting how kind of little tangential turns in life take you to new research directions.
Yeah.
My background is in biology, and so it wasn't really my field, but I kind of saw how chemistry and biochemistry labs were adopting robotics and automation technologies quite early compared to some other fields, but kind of often just as pre-programmed robots that like perform the exact same task over and over and over again. And I know that many chemists do still do all of their research experiments like manually. So what can like robot learning add within this context?
Yeah, so I think, as you rightly said, I think the field of lab automation is not very new. I think it's been there for quite a while, and I would say life sciences is even more advanced than materials chemistry.
Okay.
In that aspect. But as you said, it's all what we would call open loop. So the robot does a task, no feedback, pre-programmed. And again, myself coming from a cognitive robotics background, I was like, I'm sure we can get the robots to do something smarter. We can use the sensory information. We can get feedback from the environment. So why are we not using this? Of course, I learned quite fast that this has a lot of challenges because it's not as straightforward as deploying it. I mean, if you don't engineer everything in place, the success rate decreases quite fast. And in this laboratory experiments, they're quite long-term experiments, which means, for example, you have to run it for 7 days, a month before you can actually finish your reaction, right? So I think that makes it more challenging when you add more uncertainty and more noise into your environment. But I was very up to the challenge and thinking, oh, can we add perception? Can we add other sensory modalities? So when I think about robot learning, I work mainly on the lower level robot skill learning, or it's not just on the manipulation side, but also perception. And I think, again, this was relatively new-ish in this domain. And it was, thanks to this, I also got my Royal Academy of Engineering Research Fellowship to try and equip the robots with better skills to be able to complete more tasks. But of course, if we see robot learning at a higher level, so we have some AI-driven methods, for example, Bayesian optimizer, or now reinforcement learning, or some machine learning method that is driving the chemical reaction. So the robot is doing several tasks and it's getting feedback from the instrument, right? So this material increased by X amount. and then the robot takes the next decision to come up with another set of reactions. I think that's a bit more developed, especially using Bayesian optimization, now even generative AI models, LLMs, and whatnot. So I think the AI part of it has been there, especially the computational side, quite a while. I would say the robotics, in terms of the robot learning on the lower level skills, maybe reasoning about the robot interacting with the environment, I think that's something quite new, at least in lab automation.
So when you say skills, what kind of things are you talking about? Like different ways of manipulating samples or things like that?
Yeah, so of course, I think one thing that has been historically there for laboratory automation is we have these really nice big piece of equipment that can handle the samples for you. But these are very specific. They cost like £1 million, and it
Yeah.
can only do one thing, and it's very expensive. I think nowadays, what we like to call is more general purpose robotics. It can do many more things. So when I think about skills, using the same robotic arm or the same mobile manipulator to, for example, weigh samples. We had some work on weighing samples, and you use the same dual arm manipulator to estimate the viscosity of how a liquid flows in a sample. You can
Okay.
use the same. So one, I would say it has more perception skills, and the other one has more manipulation skills. So trying to get as much as we can from the robots in terms of handling powders, we handle solvents, we handle glassware, that kind of thing.
Okay. And is the idea that, the chemist in the lab would be teaching the robot new skills?
So I think that's one aspect of it. I would say that the chemist would be able to teach robots new skills, because when it comes to that, for example, I think one thing that we take for granted is that chemists are non-expert users of robotics. So they wouldn't have experience, although we're trying, we have the MSc programs and CDT in Liverpool that we're trying to train the next generation of chemists as well, not just the robots. But yeah, so I think making it intuitive for them to use it, especially if the robot doesn't do exactly what they want it to do, they would easily give up and not want to do it, and would prefer to do it manually, actually. So they don't really appreciate it. So I think that's one aspect of it, of getting it intuitive enough, or the other side, upskilling the chemists to be able to use the robotics. But I think both of them need to happen.
Yeah. Imagining the kind of the future of this, what do you envisage the sort of the collaboration between chemists and robots to look like? How are they going to work together?
Yeah, so I think one thing that we're very passionate about here in Liverpool is that we want the humans and the robots to work in the same lab to some extent and share the space. So we don't want to isolate, because first of all, space is expensive, especially
Sure.
in research lab and academic institutions. And also, chemists have used these glassware for years. They have used these fume hoods for years. So it would be really hard. It would take generations to change this. So how we would envision it is that, for example, scientists tend to start reactions, and they might not even carry out that reaction if, I don't know, they come in, for example, at lunchtime, and then the reaction will finish at 8 p.m., and they need to collect the sample and put it into a machine to analyze it. So I would imagine that the robot would collaborate with them to continue those experiments, that they would have been like, oh, because I came late in today, maybe I should start the reaction tomorrow. Or you have some other commitments, right, that would
Yeah.
interrupt your experiment. So that's the way I would envision them working together. I think for the time being, there's a lot of challenges in terms of deploying robot systems. So humans for now also act as supervisors
Yeah.
as well. But if I have to see it into the future, that would be the dream, where we would have robots starting the experiments and the humans continuing parts of that experiment, and then they finish and go back home, and the robot takes over. That would be a dream.
Yeah, like a robotic lab technician.
Yeah.
I mean, if you've never worked in a research lab, that might sound quite trivial, but I know, like, the brief amount of time I spent working in a lab, how inefficient it can be when it's like I have to start this experiment and then I have to wait half an hour and then I have to do another bit and then I have to keep coming back, and you feel like you waste a lot of time just not being able to actually kind of get into another piece of work. So yeah, I would have loved to have a robot to do some of that for me.
It's really exciting to hear. I think that's why we're really much in favor of having the robots share the space and the
Yeah.
equipment with humans, because then otherwise we would be separating them and it would not be continuation. And I don't think we would be able to accelerate as much as we can if we get them to team up and work together.
Yeah, definitely. And so you mentioned like having robots interpreting the results of the experiments, which sounds much more complicated to implement.
Yeah, so I would say actually, in terms of interpretation, is the easier part of it.
Okay.
If you look at the data, and of course, algorithms and robotics is quite um, better at us than I would say looking at patterns, right? So,
Yeah.
underlying patterns, I think I would say they would be quite good at. In terms of coming up with a new hypothesis, I think that's still challenging, although I think LLMs have made that even more realistic than we were maybe a couple of years ago. And I would
Yeah.
also argue that the main challenges and big challenges are getting the robots to do the same tasks as humans. So when we think about the glassware, it's optimized for human hands. And
Mm.
I would also think that a chemistry lab is not very EDI friendly in terms of inclusivity for people, for example, who don't have two hands, right? So trying to
Yeah.
do that with a single arm, most of the tasks are quite challenging as well. So I think that's why maybe humanoids and mobile manipulators can help with that. But yeah,
Yeah.
I think that's the main challenges even more than the interpretation of the data.
Yeah, you beat me to it. I was just going to say maybe a humanoid robot would be more suited to that environment.
Yeah, so I think a humanoid robot, especially the upper torso and the dual arm component, would be very helpful. I think the main reason or motivation we never considered a humanoid, because of course, gait was quite challenging, walking has
Mm.
been. And from my experience, most labs, they're also on a single floor, although now we have distributed labs as well. But the
Yeah.
experiments so far have been in the same building. So it was easy to justify using a mobile manipulator, for example, rather than having to deal with the challenges of deploying a humanoid in a lab. And of
Sure.
course, if you deploy a humanoid in the lab, if it slips because something fell, I think it's much harder to deal with than mobile manipulators. I think you kind of avoid the walking problem, right?
Sure. Yeah, yeah. So, to what extent do you think that this work that you're doing in, robotic manipulation in labs can potentially be applied to other areas, like, for example, robots in the home?
Yeah, so as a non-chemist, I always see chemistry as cooking. So
Mm.
especially when we work with materials, a lot of it you can easily find the equivalent in the kitchen. So if you do
Yeah.
crystallization and you form crystals, you can have salts or different flavors of that. Some of the materials are a bit more powdery, so I would say they're similar to dealing with flours. Glassware is transparent as well at home. We have glassware, the glasses or that we drink from is transparent. A lot of
Mm.
solvents in the lab are also transparent, so that could be the liquids that we drink. Of course, we will not be drinking anything from the lab. So I think it's more similar to cooking actually than we would think. And when you mix
Mm.
things together, it's almost like making a cake without the fun part of eating it at the end.
Yeah.
But I think in terms of robotics challenges, it can easily be transferred to household robotics.
Yeah, I've often been told I'm quite scientific when I follow recipes because I kind of see it like a lab protocol.
Yeah, and I think also chemists are quite good, or I think that they're very good at cooking as well because they're used to following recipes
Yeah.
and you analyze when you, I don't know, add too much salt or add too much sugar, how to compensate for that because probably you do it on a daily basis.
Yeah, yeah. I guess the difference that I see is that although the tasks maybe that you're doing in the kitchen are quite similar, the environment is often more complicated. There's generally not pets wandering around in a chemistry lab. So I guess you've kind of in a lab environment it's quite tidy and well structured.
If it's just robots, right? And if you have human scientists, I would say you add a bit of clutter as well. So
True.
yeah, but I fully agree. I would say that a lab is more maybe semi-cluttered, and of course, in a house, things also depending on someone's taste and design and whatnot, they would choose, for example, I don't know, cups or cutlery that would have weird geometry or different shapes. In a lab, these are more or less standardized, right?
Yeah.
So in terms of perception challenges in that aspects, they're much more simplified. Maybe the challenging part is that the materials that you might generate or create or that you have in the lab, you might not know the properties of. Whereas when you use sugar or flour or these ingredients, they're a bit more standardized than the materials that we would have in the lab. But the glassware and the rooms, definitely in a lab, it's much more simplified.
Yeah. Weird to think that a chemistry lab is like the easy version of this task.
Yeah, definitely.
Gabriella, it's been lovely speaking to you today. I've been talking to Gabriella Pizzuto from the University of Liverpool. Thank you.
Thank you so much, Claire, for having me, and thank you everyone for listening.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And if you've got a question you'd like me to ask one of my future guests, you can contact me on social media at Robot Talk Pod, on Patreon at patreon.com/Claire Asher, or at robottalk.org. I regularly announce upcoming guests on all those platforms, and I'd love to include your questions in my next interview. I thought you might like to hear a sneak peek of this month's bonus episode.
What household task would you like to get a robot to do for you?
Oh, maybe the housework.
Yeah.
That would be great. What a great time saver. Or cooking. I'm not very good at cooking, and it would free up so much time to just be able to eat rather than cook and clean the whole kitchen and wash up. So anything to do these kind of domestic tasks would just be fantastic and give me more time to do some fun things or work on my thesis. So that would be great.
You could get robots to bring you tea while you're writing your thesis.
Perfect. Yeah, I'm living for it. Yeah.
Today, in particular, I would like to have a robot who can help me moving in my house with the little activities, because yesterday I just injured myself after a football match. It would be really very great to have a robot who can bring me at least the coffee.
Yeah, definitely.
If you'd like to hear more from this bonus episode, sign up as a supporter on Patreon by going to patreon.com/Claire Asher, and you'll get access to the full catalogue of bonus content. Next week, I'm talking to Joe Wolfel from TerraDepth about robots mapping the deep ocean. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.